We have now examined both the Mercator and the Lambert's chart properties in some detail, and can see that the Lambert has both advantages and disadvantages. Looking at the positive side first, let's consider its advantages. The first is that great circles can be treated as straight lines for all practical purposes. As we said earlier, this is useful when flying with equipment that steers us on great circle tracks. Secondly, radio bearings are great circles, so they can be plotted without application of conversion angle. You still need to apply chart convergence in cases where the bearing is measured at the aircraft, but this can be achieved by plotting. No calculation is required. Finally, if scale error is small, a graduated ruler can be used to measure distances. So much for advantages. What about disadvantages? Great circle tracks are straight lines, so if we fly by compass, firstly we need to choose the track at mid-meridian, and secondly the aircraft will appear to wander off track and then back on again. On the other hand, if we wish to fly great circle tracks, the aircraft must be fitted with a system which provides automatic continuous computation of desired track. That is, INS, IRS, FMS, or GPS. Not all aircraft are. The graticule is not rectangular, so the plotting of positions is not as straightforward as on a Mercator. And, as previously stated, you need to apply chart convergence in cases where the bearing is measured at the aircraft. We'll go on to the explanation of that now. Whether you need to apply a correction for chart convergence depends on whether the bearing is measured at the ground station or at the aircraft. The easier case is a bearing measured at the ground station. If you remember, the two navigational aids which operate on this principle are VDF and VOR. It is fairly self-evident that VDF is measured at the ground station, but it may not be quite so obvious that VOR is as well. You read the information in the aircraft, but the bearing signal was modulated at the ground station. Because, for all practical purposes, great circles appear as straight lines on Lambert's charts, there is no need to apply conversion angle. However, as with the Mercator, we are going to have to put our protractor over the ground station. We cannot plot from the aircraft because we don't know where it is. This is why we are navigating. When the bearing is measured at the ground station, there is no problem. We will have to apply variation if the bearing is magnetic and we wish to plot in true. But once that correction has been done, we simply put our protractor over the ground station and plot the bearing. The line represents the correct radio path. However, there may be a problem if the bearing is measured at the aircraft. The two navigational aids to consider here are NDBs, which are non-directional beacons which provide a signal to the ADF, automatic direction finders, in our aircraft, and airborne weather radar. This plotting problem would occur if the chart convergence between the aircraft and the ground station were large enough to significantly alter the bearing. Let's see why. The bearing is measured at the aircraft. Let's, at this stage, forget about problems of magnetic variation and relative bearing. Assume that we have made any corrections required and are now dealing with a true bearing from aircraft to ground station. This will have been measured at the aircraft position using the local direction of true north, that is to say, directly up the meridian which the aircraft is on. In this example, it is 060 true. We will then need to add 180 degrees to get a bearing of 240 degrees to plot from the ground station. However, we will be putting our protractor down at the ground station position. The ground station's meridian is not parallel to the aircraft's meridian. If we simply plot the reciprocal from the local true meridian at the NDB, the bearing will be in error by the amount of chart convergence between the two positions. We could calculate the convergence between the two meridians and add it to our angle to plot. But in practice, it is much simpler to draw a parallel construction line, which we will call the false meridian, and plot the simple reciprocal from that. This is the method that is actually used in practice if the chart convergence is large enough to make the correction worth applying. Normally, we would not apply it to convergences of 1 degree or less. So, let's summarize these plotting rules. The radio bearing may be measured either at the aircraft or the ground station. These are the rules for plotting bearings. For bearings measured at the ground station, that is, VDF or VOR, first, apply magnetic variation at the ground station, if necessary. Then, simply plot the bearing from the ground station. For bearings measured at the aircraft, that is, ADF or Airborne Weather Radar, apply magnetic variation at the aircraft and heading to correct for relative bearing if required, in order to obtain a true bearing from aircraft to ground. Reciprocate. Plot the reciprocal from the paralleled false meridian at the ground station. This completes all of our work on the Lambert's chart.